All right, so the next topic today, I'm Jeff Cote with Pacific Yacht Systems. And today we're going to be talking about selecting an inverter and some inverter installation tips for your boat. So, company's been around for 11 years. You know, the big difference for us is expertise through repetition. And that knowledge and that learnings is what I'm trying to share with everyone here today. Because I would say inverters is probably within the top 5 things that we do within our business. It's one of the most life-changing things to have on a boat, unless you're a Luddite. But in terms of the benefits, what it costs and what you get, it's pretty up there in terms of transformations for a boat owner, in terms of the creature comforts that it gives, or the convenience that it gives from going from, you know, land life living to boat living. Okay? It makes it for pretty seamless transition. So what is an inverter? I mean, and that's a good question, and I'm not going to presume that everyone here in the room knows. An inverter is really a device that takes DC power and creates AC power. That's ultimately the purpose of an inverter. Now, what are the things that you want to run off of an inverter? It might be a TV, it might be refrigeration, it might be charging a computer, it might be AC outlets on your boat, right? Those are common things that inverters will run. Now, there is no limit to what an inverter can do. I've seen inverters the size of this stage and 3 times the size of the stage. Some inverters will run literally almost a small little village, right? So there is no size. But for boat purposes, you're going to limit the things you're going to run on an inverter because simply you just don't have endless power to run all loads on an inverter. But there is no limit to what an inverter can do. The true limitation of an inverter is the size and the battery bank that it's connected to. So an inverter is really the opposite of a converter. And converters are things that we see on a lot of older boats on the panel. They're going to have a labeled converter. And a converter is a charger. So the next thing is, okay, so you know what an inverter is. What do you need for an inverter? Well, the first thing you need absolutely is a battery bank. And you're going to need, remember that inverters, especially if you're going to run a microwave or a coffee machine, they draw a lot of power. Right? They draw as much as probably your windlass, right? It's easy. Like I can see, for example, a ceramic heater, like a 12 amp ceramic heater from West Marine or whatever it is, those little Canframo heaters or something like that. They're going to run at 4 maximum heat about 140 amps at 12 volts. A windlass is maybe 50 to 75 amps. So this is 2 windlasses running. And that's just 12 amps. You put 2 of those heaters there, you're drawing 300 amps. 3 of them, you're drawing 400 amps out of your battery bank. So you need a pretty big battery bank and a pretty big inverter to be able to handle those loads. So when manufacturers think about a battery bank, they're thinking at least 200 amp hours. 200 amp hours is 2 golf cart batteries in series, is 2 Group 31s in parallel, right? So it's not a big battery bank. It's a battery bank, you know, this big, or an 8D, right, which is about this big, right? So not a massive battery bank, but something, right? It can't be a motorcycle battery. It could, but the inverter would be tiny. And generally for boats, most of us work in 12 volts or 24 volts. So that's the other thing you've got to ask yourself is, when I'm going to be shopping for an inverter, what is my house battery voltage? Is it 24 or 12? Most of us is 12, and very, very few of us have 32. Maybe 1 out of 100, 1 out of 50 boat owners have a 32 volt house system. Okay, that would be more from the 70s or early 80s. Great system, it's like beta, you know, VHS versus beta. Way better have a 32 volt system. It didn't win. You know, 12 volt won. It is what it is. We can't change it. So when you're going to be purchasing an inverter, you're going to have to consider how is your house batteries wired? Are they 12 volts or 24 volts? All right, so the next question you have to ask yourself when you're thinking about an inverter is, what's the purpose? What am I going to do with this inverter, right? Because not everyone uses an inverter for the same purpose. So common things that people want with an inverter. I want to run for example, my partner wants to run the microwave without having to start the generator, right, in the morning. That could be one. I want to have my coffee machine, like an espresso, run in the morning without having to start the generator. That's another one. I want to run a TV at night in an anchorage and not have to run the generator. That's another one. I want to recharge my power tool batteries right? Again, whenever, without having to be connected to shore power or running a generator. So you can see like all these things are possible without connected to shore power, without having a generator running, but you've got to look at the back of every single device. They're going to talk about the wattage. You know, some microwaves, very, very compact microwaves, are only about 600 watts. Some microwaves are 900 watts. Some microwaves are 1200 watts. So you've got to start figuring out the size. A hairdryer might be 1400 watts, 1600 watts. So you got to think about what is the purpose of my inverter. And that's going to allow you to figure out what is the wattage of my inverter. Because inverters come in all sizes, okay? Obviously, you can even buy them smaller than 300, but you know, why bother? So you basically start at about 300 to 600, right? What are the things you're going to be able to do? Like for example, I have a 300 watt inverter on my boat, and here's what my 300 watt inverter does. It runs a 40-inch LED TV. It runs 2 media centers, laptop charging, iPad chargings, basically every kind of little nitbit, small little thing, and it's on 24/7. I leave it on all the time. Anybody want to plug in anything? It's very low power draw because it's only 300 watts. Anybody wants power, they just know that outlet is always powered, and it's easy breezy. So that's what a 300 watt, it won't run a vacuum. I can tell you that. My cousin tried to run it, blew the breaker. So they will not run a vacuum. But it's going to recharge devices, and it's going to run a TV and charge computers, no problem. 1,000 watt inverter. Now that's a little bit more popular. What is a 1,000 watt inverter? Might run a small microwave, small blender, right? And then a 2,000 watt inverter is going to run what? Like a coffee, an espresso machine, right? And it goes from there. There's 3,000 watt inverters as well. That might be concurrent use. Someone in the galley using a microwave and someone else using a coffee machine at the same time, concurrently at the same time. So those would be the range that you're thinking about. At 12 volts, the biggest one is 3,000 watt. 24, you can go 4,000. And I have owners that go, and we're doing a boat right now, it's 8,000 watts. You start stacking them, right? You can have 4,000, 4,000. I was on a boat this summer at Royal Van, 16 kilowatts, 16,000 watts. He can run washing machines. The whole thing, his whole boat can run off the inverters. I mean, it's industrial, but that's what he wanted, and that's what he has. So there's no limit, of course, but the range is really between 300 and 3,000 is for most of us, is the range of the inverter that we're going to choose on a boat, okay? All right, the next big question is, okay, now you figured out, A, you've got a battery bank to run it, because you need a battery bank. You figured out what the voltage is, so you know that. You figured out the size of the inverter you want. The next question you've got to ask yourself is, okay, what type of loads am I going to be running? Because there's a big difference in AC between what are called resistive loads and inductive loads. And you're probably, what's a resistive load? A resistive load is a toaster. Resistance, that's what it is, it's eating element. Let's say a heater itself is a resistive load, like a light, old lights, right? Incandescent light bulb, that's a resistive load. Inductive loads are motorized loads, like a Nespresso machine. An owner of mine replaces Nespresso 3 times. First time, terrible product. Second time, Nespresso makes an awful product. Third time, what? Oh, and the third one worked at home, but it broke on the boat. Maybe Nespresso's not the problem. What could be the problem? Get a phone call, go on the boat. He's running a modified sine wave inverter. Modified sine wave inverters are not good with inductive loads. They're less expensive than true sine wave, and they're not good for recharging, power tools, batteries. They can't do that. Your microwave is going to run great on the generator or shore power, but it's going to take forever to warm a cup of coffee or a soup on the inverter. That's because you're running a modified sine wave inverter. Your TV has a line going through it. You can't see it, but generally your partner can, and it's driving you crazy. That's a modified sine wave inverter. Your thruster controls, which are connected to a DC battery, are humming. That's a basically modified sine wave inverter that's making noise. So anything crazy or interference, you turn the inverter on and your autopilot's working and the boat veers off like 70 degrees to port every time the toaster comes on, that's a modified sine wave inverter. That happened when I got my boat, didn't know. Karen's down below. we basically suddenly someone turns on the making toast, the boat goes 70 degrees to port. That's a modified sine wave inverter. So all those reasons are a lot of negatives, right? I mean, let's be honest, there's not a lot of selling points. The only reason people buy modified sine wave inverters is for cost. And back in the day, 10, 15, 20 years ago, it was a big difference. It was substantial. But nowadays, when you can buy a true sine wave inverter for between 40 cents per watt to $1 per watt, maybe $1.10 per watt, there's really no incentive, in my opinion, to run a modified sine wave inverter. Now, your choice, your boat, your rules. But to give you an idea, I have never installed a modified sine wave inverter in 11 years in my business. I've never installed one. I always try to encourage the owner to go the true sine wave route for all the benefits that I talked about. But you know, maybe for you, you don't see it. That the only thing you're going to do with your boat and your inverter is going to make toast. Well, then an inductive or a modified sine wave inverter is perfect for you because it's going to be certainly less money, okay? Oh, the other thing too is, by the way, also a modified sine wave inverter is less efficient at converting DC power to AC power. So the other thing too is you don't care about power on your boat. You have lots of it and you don't care if it's inefficient. You lose about 30%. So again, it'd be sort of like doing a conversion on your American dollar to Canadian dollar. Instead of losing 2% on each side of the transaction, you're losing 35% on each side of the transaction. So that's pretty significant, right? A true sine wave modern inverter is going to cost you between 5 and 10%. Modified sine wave old inverter, around 35%. So considering that battery banks are a finite capacity, and battery capacity on a boat is like money, it's very valuable and it's rare, to lose 35% on your transaction to convert DC power to AC power is a pretty big deal. And I honestly have done some boats where the only reason the owner changes the inverter is just to get the energy savings from going from modified to true. That's the only reason. Owner takes it out, works perfectly fine, gives it to a friend, sells it to a friend, puts a true one in, and saves literally 30% on his power for all inverter loads. And that can add up a lot, because some refrigerators on a boat run only on shore power. So you got a refrigerator, a deep freeze on the flybridge, refrigerator down in the galley that's AC driven, you're attacking on 30% more power consumption because you're running a modified sine wave inverter that's outdated. Okay? So that would be another thing to look for when you're shopping for an inverter. The other thing too is when you're looking at an inverter, one thing that you can consider, and that's certainly the reason why I ended up buying a 2,000 watt inverter. So I have a 300 that I leave on all the time. But the reason why I wanted a 2,000 watt inverter is not really for the 2,000 watt, although that was really good to sell it to other stakeholders. The real reason is I wanted a high charge rate. I have an 800 amp hour battery bank, and remember the minimum charge rate for a battery bank is 10% of battery capacity. So 10% of 800 is 80 amps, right? But with flooded, I can go all the way to 25%. So I got a 100 amp charger with a 2,000 watt inverter. And that's the reason I put a 2,000 watt inverter on my boat, is so that I got a 100 amp charger. And with the 100 amp charger, I got a 2,000 watt inverter. So for me, the justification and the drive to going to a 2,000 watt inverter was to get a 100 amp charger. So one stone, two birds. And remember, give you an idea, a 100 amp standalone charger is about $2,000. A 2,000 watt low frequency, so good quality inverter charger is about $2,000. So they're the same price. And why would you have two instead of one? It's because inverter chargers sell 100 to 1 to a single standalone charger. So they have mass production. The cost per unit is so much more down on an inverter charger than a charger. So it's cost effective to actually buy an inverter charger versus just a charger.
They got different profiles?
Yeah, different profiles, absolutely. Yeah. All right, so when you're going to be buying an inverter, what are other things to look for? First of all, you want to make sure that it's marine certified. And I could take 10 minutes to explain why, but there is some automatic switching that happens between the neutral and the ground on an inverter, and that is absolutely essential, and it gets unswitched and reswitched depending if it's a source of power. And a non-marine inverter won't do that. If you care about your underwater metals, meaning you care about straight current corrosion, and you value money, I highly recommend that you choose a marine certified inverter. Sort of like a marine certified charger is the same thing. If you don't value money and you don't care about losing your underwater metals like your prop, your struts, right, your legs and all those things under your boat, then yes, a Canadian Tire inverter or a Canadian Tire charger is right for you. But for everyone else that values money and they want their boat to operate and they don't want to lose all their metals and they don't want straight current corrosion, I highly suggest and tell you that you buy a marine certified inverter charger. The other thing too is make sure what is going to be that efficiency of the inverter. You want an inverter, of course, you go from 12 volts to 120, of course it's going to be a factor of 10, right? 12 into 120 is 10. There's going to be a factor of 10 to convert. But on top of those 10, how much to convert from AC to DC? A modern, really efficient charger is going to do it within about 5 to 10%. Inefficient, inexpensive chargers are going to do it within about 35%. So that means you use a lot more of your battery power to do the same thing if you buy an inefficient or an inefficient inverter. The other thing too that's started to happen, and that's a little bit more sophisticated, is that now inverters have what's called a power assist mode. So your boat might have only 30 amps or 50 amps coming in, and sometimes you have surge loads that are inductive loads. The air condition comes on, a water maker comes on, a dishwasher comes on, some large load comes on that kicks you over 50. What can happen is the inverter for a short period of time can actually take that difference and suddenly give to your boat 70 amps of power. So your inverter can actually supplement your shore power connection as a way to avoid tripping your shore power breaker. Different companies have different names for it, but that's kind of convenient. You might only have, maybe in your boat, you only have 30 amps. And sometimes, just for a short period of time, you need 40 amps for 20 seconds, for whatever reason. Some inverters will allow you to get the 40 amps even though you're connected to only 30 amps. So the inverter will actually sync with the shore power and will add another 10 amps to the 30 amps that you're getting from shore power to avoid the shore power breaker from tripping. Essential is that your inverter has the ability to be disabled, meaning that it actually, you can say inverter off. And this is going to be really key, especially when you're not on board the boat and you don't want your inverter to automatically turn itself off when it senses that there's no AC power coming on the boat. I've had a lot of boat owners that have been very sad to find out that they lost shore power in the winter. Their inverter was on standby. They had heaters on board. Shore power got lost because of a storm, whatever happened, someone kicked the cord. Their heaters now were running through the inverter from the batteries, and within 2 hours the batteries are dead. And a battery that is left uncharged for a week, 2 weeks, a month is a dead battery forever. There is no coming back from the other side if your battery is left uncharged and completely depleted for any period of time. You can bring a battery to zero, you can do it, it's going to be very damaging to the battery, but you have to recharge it the moment it gets to zero. The longer it stays in that uncharged state, at one point it's a lost battery. I had an owner, I met him again today, he went on a traveling trip, a friend disconnected his shore power cord, thinking, oh, I need more power. But what he didn't realize is when he pulled the cord, the breaker tripped, right? You can't disconnect a shore power cord under load. Person didn't think about that. Pulled the cord, breaker tripped. He reconnected, but the breaker never came on. The heaters were on. They ran off the inverter. It was a $6,000 AGM battery bank, just batteries. He came back. He had a $6,000 bill just for batteries. And that doesn't include taking the old batteries out and putting new batteries in. So your inverter has to have a disable button, a inverter off button. Very essential, okay? Do not buy an inverter that's always on, because there's maybe unintended consequences when something else happens. You might want to consider an inverter that has a built-in charger. Certainly a little bit more time to install, because an inverter with a built-in charger needs an AC input. But since you're already running a wire to the AC out, you're running 2 cables or 1 cable, it's not that big of a deal in terms of labor. So I would say 95% of owners, boat owners, are choosing to buy an inverter charger, right? Because then at the same time, they're getting a battery charger and an inverter. Maybe 90%. So that's something to ask yourself, do I need a larger charger? Maybe I'm changing my battery banks because I'm putting an inverter in, and if it's a larger battery bank, how am I going to recharge that larger battery bank? A large inverter charger will give you that. And then another thing too is that, and I'm not a big fan of it, although some of boat owners do like it, is there are modules that come with different brands of inverters where the generator can automatically start if the battery voltage is too low. I personally believe that a generator should only be started by an operator and that a machine shouldn't decide when your generator should turn on, right? Because that generator doesn't have a sense if the seacock is open or closed, right? It doesn't know. So you could have the seacock closed and then the generator starts, the cooling is closed, damages the water impeller, right? It could be pretty catastrophic. In my opinion, a generator should be started by an operator. But some owners like convenience. They want automation. And so if that's important to you, there are different manufacturers of inverter chargers and inverters that have automatic generator start modules that can be tied to the inverter. So whenever the inverter sees a low voltage and doesn't feel that it can provide enough inverter to run your loads, the generator will kick on automatically. This is a typical wiring schematic. At the bottom, you can see a generator, a shore power. There's a source selector switch right here, right? Power goes into the inverter. The out of the inverter goes to the panel, routes some outlets. The inverter is powered from this battery bank, which is your house battery bank. There's an echo charge that allows this charger to charge 2 battery banks. Battery monitor. It's a simplified diagram. It's a one-line diagram. It's not completely accurate. We'll talk about a more accurate one. But it kind of gives you a sense of how an inverter is wired. You would not wire an inverter like that. But this is kind of like, let's not get it too complicated. This is right enough, but not completely accurate. So now that you've figured out which inverter you're going to buy, how do you go about installing one? Well, first thing you got to ask yourself is, what loads am I going to run off my inverter? And remember, it's very rare that I have an owner that says, I want to run all my AC loads on my boat on an inverter. When we install an inverter, I always like to make it foolproof. Foolproof is, for instance, not having the battery charger run off the inverter. And by the way, I've seen that often. So you have your inverter that takes powers from the batteries, creates AC, AC runs a charger to recharge the batteries. Now, Da Vinci's, eternal machine of power or whatever it is, that has not existed, okay? There is no such wheel that creates power endlessly. So you can't take power to make power to give it back. And I've seen it often. And so that would be one load that you wouldn't want to run off an inverter. You wouldn't want to run your battery charger off an inverter. So that would be a load that you would choose to take off. Another one might be your hot water tank. Even though you might want it, a hot water tank is generally a 20 amp circuit. 20 amp circuit at 12 volts with your efficiencies, it's probably going to be a 220 amp load. Think about a 220 amp load on your battery bank. That is a massive load. Your windlass is maybe 50 to 75, right? This is a huge, huge load on your battery bank. And that load is going to run for 30 minutes. So if you have a hot water tank on your inverter, you need to have a very, very, very large battery bank. And so I always advise owners, I'm like, it doesn't make sense to run your hot water tank on your inverter. It just doesn't. You might have a water maker. You can't run that on it. You would need a massive, massive inverter system to run. You'd be like my other boat owner that had a 12 kilowatt or 8 kilowatt, because a water maker has huge inductive loads, right? Kickoff, same thing with air conditioning. You can run an air conditioner off an inverter, but you need a large inverter system and a large battery bank system to do that. We've done that with lithium. Of course it's possible, but for most of us, it just becomes too much of a burden. So you choose the loads that are going to run off the inverter and choose the loads that won't. Okay, and that's part of the first step that you've got to decide when you install your inverter. Here's an example of Blue Sea shows you kind of like a one-line diagram. And that's kind of the terminology we use. We got non-inverter loads, hot water, air conditioner, it could be in here, it could be, I don't know, water maker, garbage compactor, whatever it is. Those would be non-inverter loads, loads that only work from shore power or generator. And then you have inverter loads. And notice the inverter is down here. And here's the input, and there's a breaker, very essential. There's a breaker before the inverter. The inverter's here, and then there's out. And then this microwave, outlets, lighting, it could be entertainment system, Bell Express View, you got a satellite TV system, whatever it is. Now notice when you're connected to shore power, the inverter loads are effectively going to be run through a mode called bypass or pass-through. So everything is going to be running off of shore power, even with the inverter off. If you lose shore power and the inverter is enabled, all the inverter loads are going to be powered. If the inverter button is off, you lose shore power, all your inverter loads are not working. Okay? That is, I would say 99% of all our installations follow this schematic. That's how we do it. In non-inverter loads and inverter loads. So I want to emphasize that it's really important that your inverter charger has to have a breaker at the source of AC power coming to the inverter charger. You want to make sure that the AC wiring is not solid strand home wiring to inverter. You'd be shocked. A lot of boats from the 80s didn't have AC systems, or 70s, and it got retrofitted. And cost is king, right? Just get it done. Cheapest is better, right? And people actually installed literally like solid strand copper wiring on boats from the 70s and 80s. So make sure that you're using green gray wire. I'll show a picture about that. And here's the big kick, and that is probably 95% of all non-professionally installed inverters have this problem. First of all, if you ever read an inverter charger manual, it's about, and I'm not going to joke, it's about not a centimeter thick, but half a centimeter thick. It's probably 100 pages. Any self-respecting man is going to see that manual and he's going to see the inverter box and say, this is just stupid. It's a waste of my time. I'm smarter than this. And they'll take the manual and they're going to use it for any other purpose than reading material. And they will then dive in on the installation, MacGyver style, and they're going to get it to work. And at the end of their project, they're going to really be proud of themselves because the inverter will work, but they're not going to have read anything. And it's not going to work safely, but they don't care because as long as it works, it's MacGyver. So one of the most missed things on an inverter install is the fact that when you separate your panel, you don't only intercept the hot leads from the breakers, you also have to find the neutrals and bring them to a separate neutral bus. So you have a neutral bus for non-inverter loads and a neutral bus for inverter loads. Your boat's not going to be wired like that. You're going to have to literally peel the loads off and create an inverter bus and an inverter bus for your neutrals. And that is probably missed in, I would say, 95% of all inverter installations because no one is going to read an inverter manual because it's just, who would? It's too thick, right? And the other thing too, a lot of inverters, if you've got a boat and it's really questionable about the work that was done on board, a lot of boat owners, not reading the manual, are going to install an inverter directly connected to shore power between their AC panel. So they're going to literally go in and they're going to pop the inverter in between their AC panel and their shore power plug. They're going to be like, well, if I don't have shore power, the inverter is going to run my boat. And that would be a boat where the hot water tank, the battery charger, and all these things are run off the inverter. There's no circuit protection generally in those situations because the circuit breaker on a boat is generally not at the shore power receptacle, it's actually on the AC panel. So that whole line is unprotected. I cannot tell you, there's so many reasons why that is wrong, but that is very common. If you got a guy that did work on the boat for a case of beer or for whatever, then he probably installed the inverter in line between the shore power receptacle and the AC panel. Because again, he probably didn't read the manual. Definitely no, okay? So look, this is what AC wiring, and it's kind of hard, but you want to have wiring that is basically fine strand, tinned, right? Flexible so it won't break. Very essential. If you're going to install an inverter on your boat, make sure that the inverter never is mounted in a gasoline engine room. Yes, chargers are in gasoline engine rooms, but inverters cannot be mounted in a gasoline engine room because there is no such thing as an ignition protected inverter. Many owners, I would say, anybody who's got a gasoline boat and has an inverter, I'd say probably half of you have the inverter in the gasoline engine room. Why? Because the batteries are there, and there's a charger there, and whoever put the inverter saw a charger and said, well, if the charger's good here and the batteries are here, where am I going to put the inverter? It's got to go in the engine room. What they don't realize is if ever there's a fuel leak, maybe a fuel leak from the fuel filter or fuel leak from one of the hoses leaking fuel, that fuel has a very, very, very low flash point. Doesn't need a lot to ignite. It's not like diesel. Diesel, you can throw a match on it, it won't light. And the other problem with gas is the reason why it's also called gas, probably not just gasoline, coincidentally is it's very gaseous. Like it actually expands, right? That's why people in the summer blow up from their lawnmower sheds, you know, and they have no ventilation and the tank was open and the whole space is filled with gasoline. They open the light, the shed explodes. Well, that's what happens. It goes everywhere. A whole compartment is going to be full, especially in the heat. It gets warm. And so it's essential that your inverter, and remember your inverter is going to be, you're not going to have the blowers operating when you're going to be installing your inverter because your engine's not working. You're going to be sitting in anchor. So the code is very black and white about this. There is black and white. An inverter charger cannot be mounted in a gasoline engine room. So essential that you install it within the cabin of the boat. But then some people do that and drill huge holes and they break the, and by the way, this is 95% of all installations. People forget the huge hassle that builders go to make sure that a gasoline engine room is completely vapor-proof from the cabin. Like massive costs, insane costs to do that. Then people go in and they take hole saws and they punch holes through. And I cannot tell you how many people are proud of having their inverter chargers in the cabin, and there is literally a hole this big between the cabin and the engine room. Now their whole cabin of their boat is part of the engine room because any vapors from gas are going to go through that hole. Craziness. And now people are living, families on board, kids, and if that inverter ever turns on and there's a gas leak, there's going to be an explosion. So really essential, if you're installing on a gasoline boat, you need to make sure that those wires going through the bulkheads are absolutely vapor-proof. The other thing too is you want to make sure that the inverter is mounted in a dry location. It can never be exposed to spray or water or rain. Make sure it's in a good ventilation. I have owners that put it in under a settee and it's all closed. Inverters create a lot of heat. You're going to need ventilation to that, like some sort of louvered vent. It will shut down. If you have it in an enclosed space, sort of like if I go in a freezer, you close the door, I'm going to die both of lack of oxygen and the fact that I'm going to heat that space up and I'm going to cook myself. It's just I cannot breathe. Inverters are creating heat. If there's no ventilation in that space, the inverter will shut itself down through overheating, and it's going to give you overheating error. So it's really essential that your inverter is not mounted in a location where there's no ventilation. And the other thing too is an inverter cannot be mounted, you want to mount it as close to the batteries as possible, but you don't want to mount it directly above the batteries, especially for flooded lead acid, because flooded lead acid batteries, when they charge, especially in bulk, create a lot of gas, and that gas is corrosive and it rises. And so you're going to have premature failure on your inverter because you've got too much gassing. So the manual says all of this, but make sure that your inverter is close to the batteries, but not above them. So here's an example on a Grand Banks 36. I did that in 2008. You can see the switch, you can see the inverter, the fuse. We'll talk about that a little bit later. Fuse. When you install an inverter, you want to have the right fuse, the right amperage of the fuse. You want the fuse to be located in the right place. So you want a Class D fuse. You want a fuse size that is specified by the manufacturer. It's going to be in the manual. And you want to have the fuse located at the beginning of the circuit. Very essential. Not anywhere in the circuit, because that fuse not only protects the inverter, it also protects the wire feeding the inverter. Okay? Very essential. And also, believe it or not, it's really hard to find a Class D fuse in a chandlery the further north you go. Like, don't think you're going to find one in Refuge Cove, for instance. Okay? So, and remember, your inverter is not just an inverter, it's also an inverter charger. So if you lose that fuse, you lose your inverter and you lose your charger. That's pretty critical, right? Even if you have a generator on board, now your charger will never work because you don't have the fuse. So it's really essential to have a spare fuse. Otherwise, you're going to do something like this. And the owner never did it. It's just the previous owner never fixed it. Yeah. And by the way, this is actually quite common. This is not a joke. They kept the fuse holder, though, which is kind of nice. So they have the intent of the fuse holder. But they just, yeah. They figured the wire seems a little smaller, though. So that's probably going to catch on fire before the other wire. So they did put a fuse. Yeah. And notice it's in front of an engine, and the engine is all negative, right? So if you touch one and the paint chips, you'd have an Indiana Jones mastercraft in your hands forever. You know, I mean, the welding would be amazing. It would be like, you'd be burnt like 3 degrees. Your hands would be seared on that thing. Like that wrench would be dead hot, be like lava hot. So yeah, so they use a wire as a fuse. And this is a Class T fuse holder. Well, I mean, those people are not, the wire. I mean, I would love to meet these people one-on-one with a beer. I'm like, what were you thinking? It'd be incredible. Another thing, too, is when you install an inverter, and this is often overlooked, again, it's in the manual, you want a master DC disconnect switch, an on-off switch that will disconnect DC power to the inverter. Now, that's what the code says, so as an engineer, I'm thinking, well, why? Right? I'm always curious. Well, the reason why is it's sort of the same way when it's called a service disconnect in some ways, because if you're ever going to play with AC on your boat, change an AC outlet. What's your first reaction or first instinct of what you should do before you're going to change an AC outlet on your boat? Personally, I would disconnect the shore power cord. I'm not going to turn off the breaker of the panel. I'm not going to take a chance. Why not disconnect my boat from shore power? Why trust a breaker when I can physically disconnect my boat from shore power? That would be my instinct. The problem is if you have an inverter on your boat, inverters have this thing that's called a standby mode. Standby modes means I'm an inverter, but if I don't sense a load, I'm not on. So now you have a little wand from Home Depot and a GFCI tester, and you put it in your AC outlet. Your inverter's on standby, there's no load. You put it beside the AC outlet, no beeping. You put your GFCI in there, it's like a 5-watt load, no light. You're like, this is amazing. I am prepared and ready to take away that GFCI and change it. There is no electricity, AC electricity on my boat. You disconnect, you touch the hot and the neutral. Suddenly the inverter says, oh, wait a second, I sense more than a 50-watt load, right? Because your fingers is definitely more than 50-watt resistor here. And it'll be like, I think I've been asked to turn myself on. So now you're going to get electrocuted because your inverter was on standby mode. And hence, why inverters have a master DC disconnect. And the master DC disconnect should be labeled. And it's not something you'll ever touch unless you're working on your AC system. Okay? So you don't need it, but you sure do. You know what I'm saying? That's why the standards say so. And the other point that I'm trying to say there, especially if you have an inverter charger, and this is essential and often overlooked, often, probably 2/3, well, 1/3 of the boats don't do this. People are very incented to take shortcuts. We all do. We're all trying to be efficient. We're trying to do things faster, better. What the issue is that people will wire an inverter charger at a panel because they don't want to go all the way to the batteries. And they're thinking, well, the batteries are too far. There's already a big cable there. Why would I bother? I'm just simply going to connect to the panel, connect to this switch, and it's already a switch location, switch distribution we call it. So they run the inverter to that, and they're like, oh, look, I just saved all this wire. I don't have to run another 10 feet. So then what happens is the owner of the boat goes, the charger's on, by the way, at this point, and the owner says, and this happens all the time. The owner goes, oh, I'm going to disconnect my batteries from my loads. And it takes the main DC disconnect for the boat, turns it off. But now suddenly, all the loads are still on. And then you're going, what the hell? I just turned the batteries off. And you did. Now your battery charger is acting as a power supply. Now, a power supply and a battery charger are two separate things, and a power supply is way more money than a battery charger because a battery charger assumes that there is a battery there to take the shock loads of the battery voltage going up and down. A power supply is able to hold steady regardless of the voltage, loads coming in and off, and it's going to hold at 13.3. A battery charger does not react like that. So now you have your inverter charger running all your households on your boat, besides the point that it's freaking the hell out of you, right? You're like, what the hell? My batteries are disconnected. How can I have charge? Now you're wondering, where's the short? What's going on? And then suddenly what you do is you have maybe a load that comes on. It takes a time for the charger to react, right? The voltage drops, light go dim, and then come back on again. But now what you do is you take the load off. Then that's where you're going to pay a price, because the charger does not react instantly. If you have 300 pounds on top of you and suddenly the load is gone, you're going to push up. Voltage is going to spike 18, 20, 24, 25, 30, because the charger is putting output of amps. It doesn't know that you're suddenly going to take away a load, and it's not connected to battery, and suddenly you're going to have a voltage spike, and now all your sensitive DC electronics that were actually connected at the time are going to blow up. So that's the reason why you always want to have an inverter charger, or all charger circuits, alternators, chargers, inverter chargers, directly connected to a battery and not switched, except if they have their own switch, right? Because if it's own switch, the inverter won't be able to draw from it, and the charger, it's lost both links. Okay, so it won't matter, but very essential. So an inverter charger has to be directly connected to an unswitched connection at the battery via its own dedicated fuse at the battery and its own dedicated switch. And that's what the code says, and that's how they should be wired, but most boats are not wired like that. I was on a boat, it happened a week ago, Grand Banks 42. Beautiful boat, beautiful, amazing. You would think this boat is wired perfect. And it happened when we were on board. There was a dead short on the engine. The charger was actually connected directly to the load side of the switch, not to the battery side. We shut off the engine battery switches, but the dead short was still happening. And there was a fire in the engine room while I was on board and the owner was there. Extremely scary stuff. Couldn't disconnect it. We were like, what the hell's happening? It was because the charger was connected to the load side of the switch. So the engine was always on. Even you could have the engine switches off and the ignition panel will be powered. You couldn't start the engine because the charger is only 40 amps. The voltage would crash. Right? It can only power 40, but the ignition would be on, the gauges would be on, everything was on. You think you're connected and your engine switches was off. Very confusing. Okay. DC wiring. Make sure that the wire size meets the amperage or the wattage of your device. If you have a 1,000 watt inverter and you're switching to 2,000 or 3,000, unfortunately the reality is that the wire size feeding that 1,000 watt inverter is not going to be sized for 2,000 or 3,000. It's not like a AC outlet where you can plug whatever appliance you want. In DC, because the wire size are so big and so expensive, people only use the cable size that they need. They don't oversize everything for multiples of what they need. So make sure that the wire size can handle the amperage and will offset the voltage drop of that. So there's a table in the manual, and it's going to tell if the run to the inverter is 10 feet and 10 feet back, you've got a 20-foot run. There's going to be a table that says 20-foot run, 2,000 watt inverter, you need 4 aught, right? And you got to follow it, okay? Make sure also, and I've seen that happen, is that sort of like a carotid artery, right? Carotid artery, someone who's not in shape, sitting on the couch, watching TV, it doesn't matter that tons of cholesterol, carotid artery, no big deal. So the inverter might see 12.8 volts, everything's good. You're like, oh, I got a crimp, everything's done. But that's because you're not asking anything of it. You say, I'm from the East Coast, you do the same person. You say, now there's 3 feet of snow in the front yard, go shovel. Right? That same person sitting on the couch is completely fine, not breathing, everything's okay. Now you ask him to go shovel snow for an hour and a half, he's going to have a heart attack in the front yard. Well, your inverter is the same thing. You could have 12.8 volts, perfect connection, under no load to the batteries. But if you have a bad crimp on that wire and you're running 200 or 300 amps continuous, that crimp better be perfect. So make sure that your crimps on high current draws to an inverter or a thruster or a starter are perfect. Otherwise, a starter is only 15 seconds. Thrusters maybe 5 seconds on and off, but inverter can be continuous. Maybe a partner is having a hairdryer, 25 minutes. You've got a few teenage girls on board. Maybe it's going to be 60 minutes of hair dryers. Who knows? That load is going to be pretty hard, and you better make sure that your crimp, i.e. the lug on the wire, is perfect. Also, and this is not seen as essential, and the MacGyvers out there are going to say, well, why would you ever have a shoulder on a highway? What's the purpose of having a shoulder to pull over? Because my car never breaks down, and the car in front of me never breaks down, and we're always simply going to run. Because they're optimists, right? But some of us know the reality is sometimes a car breaks down and it can't actually park on a highway, it needs to pull over. A chassis ground on an inverter is basically the equivalent of a 3-wire AC system. And we've been to 3 wires for over 100 years, okay? Old houses were 2 wires, hot and neutral. Eventually someone figured out that there needs to be a secondary path to return because the path to ground could be you. So they have what's called a grounding wire. If you do not have a chassis ground on that inverter, you are willing to say the last 100 years of progress were stupid, and I am going to go back to circa 1898, and I'm going to do a hot, neutral AC system on my boat. Now, yes, of course it functions. Everything's fine until it doesn't. And if there's no chassis ground and you touch the case and it's energized, this will be the last inverter case you will ever touch. You'll get electrocuted and you will die. So essential to have chassis ground, and I'm not joking, probably half of all inverters don't have one because you don't need one, right? It works without it. Sort of, you don't need a seatbelt in a car to drive it, so you don't need it. And if they do have one, they didn't read the manual, and the cable size is gauge 10, because most people that wire boats are household electricians, and again, they didn't read the manual. And the manual says that it needs to be one size smaller than the largest cable size connected to the inverter. So if you're feeding a 2-aught inverter, you need 1 aught on the chassis ground. Because if you don't, and the chassis ground shorts to 2-watt positive, that 10-gauge wire becomes a fire wire, and you will lose your boat guaranteed. There's no amount of fire extinguishers. There's nothing you can do. Your only source is to get off the boat because it's going to be a volcano that's going to turn on your boat. That length of wire will go full-blown, will light up like melted lava on your boat. So you can never, ever, ever, ever have a 10-gauge wire as a chassis ground fed with a 2-watt positive wire. You can, but you're asking for trouble. And I talked about that a little bit. So if you're going to use your inverter charger, make sure that you turn your inverter function off, right? Never, ever, and this is important, especially with an inverter charger, and the labels are misleading because they only say inverter on it. But on your AC panel, you might have an inverter, and it's going to say inverter. You're thinking, oh, well, I'm going to shut it off there. If you have an inverter shut off and you turn the breaker off, you're shutting off the charger function as well. And I've had owners where they lose their battery banks because they're looking at the panel like, oh, I don't need my inverter. You boat owner, right? No, I don't need the charger. Shut it off. They walk away. 2 months later, they come back. Their batteries are dead. Why? They turned the battery charger off on the inverter function. So never turn your battery charger on the circuit breaker. Always on the remote panel or the inverter. And lastly, just to wrap up, think about this. As an inverter charger, it's not just a device that runs a light in your cabin, right? That inverter might run your refrigeration. So if you lose that inverter, you lose the food in your fridge because that inverter is running the loads pass-through. Meaning if the inverter dies, even on generator shore power, the fridge won't get powered. You need to literally take it off and jump those AC wires together. Now, not many people are going to be willing to do that. So then what happens is they go to Campbell River, they go to Nanaimo, they go to Sydney, and then they get another inverter. Now, those are easy points of entry, but if you're up in Discovery or Browns and you use your inverter, your fridge, if it's running off AC, is done. And now it won't run on shore power, and it won't even run off of a generator. So when you install an inverter charger, make sure that at one point, don't push your luck. If you've got a 20-year-old inverter charger, at a point you got to ask yourself, how long is that inverter charger going to last? And in the summer, I probably change about 2 dozen, and I never change some in the winter. They fail under use. That's when we get called out. So if it's critical to you, an inverter charger, and you have one on your boat, you got to ask yourself, how much luck can I have with this inverter charger, and what happens if I lose it? Is it just I'm not going to run the microwave? Big deal, right? Maybe my AC outlets are not going to work. Or am I going to lose some essential loads like my refrigerator on top of the flybridge, and I'm going to the Browns for 2 months? And then everything on board, I won't be able to do connect to shore power or anything. Nothing is going to run. So those are things you've got to think about how critical your inverter charger is on your boat. And with that, I'm going to let it go because we've got about 2 minutes and someone else is in the room. So I'll take questions on the outside. And thank you, everyone, for your time.